Okay. So today we talked about, well, the other day we talked about graphing of systems of equations. Today we're going to go through the other two methods that you can use to solve systems of equations algebraically. We're going to look at substitution and we're going to look at elimination. Next week we'll do the word problem ones, which is, in essence, you're going to use these methods to solve the problem. So substitution is exactly what it sounds like. We're going to take an equation and plug it into something else. Substitution works really, really well when you have one of them solved for a letter. Or if one of them has a letter by itself that's easy to solve for. So in this case, I got 2x plus 3y equals -6, and y equals 3x minus 13. So if we look at it, this equation right here is already solved for y. So because of that, substitution makes sense. So to do your substitution, you're going to take the original problem, the other problem. So I have the 2x plus 3, and where I see the y, I'm going to put the other equation. So the only thing I change is that y. Questions with that? Does that step make sense? Great, that's the substitution step. Now we're just solving an equation. So the first thing I'm going to do is get rid of my parentheses. So that times that, and that times that. So plus 9x minus 39 equals -6. So combine like terms, so I have 11x minus 39 equals -6. Add the 39 to both sides. Equals 33. And then divide by my 11, so x equals 3. Once we have x, we still need to find y. The nice thing about the substitution process is one of the equations will solve for that the other letter. So it makes it really easy to plug in. So I'm going to take that x now and I'm going to plug it into my other equation. So y equals 3 times 3 minus 13. 9 minus 13. So y equals -4. And there's my answer. So my point is 3, -4 is the intersection point. I got to see how they actually want you to write this. Oh, they actually want it as x and y, so you just separate them out. If you don't like having to do more problems than you should, which everybody should like that, you can substitute the problem back in, like the actual points, to see if it works. You don't have to worry about the one that was solved for the letter because you used it already. You really just have to try the point in the other problem. So if I take this 2x, the 2x plus 3y equals -6, I plug in the numbers. So 2 times 3 plus 3 times -4 equals -6. So 6 minus 12 equals -6, and that's true. So as long as it works in the other problem, I know that's my answer. And I know I didn't get it wrong. If it doesn't work in that other problem, you know you made a mistake. Go back and look. Okay. Also, I rarely see these problems giving you really strange numbers. Right. So if you get things with decimals and stuff like that, odds are something's wrong. So go back and look at it. You will get some even fractions like 9/2 and things like that. That can happen sometimes, but even those, I'd go back and check just briefly, just to make sure you didn't make a mistake. But yeah, if you get something crazy where you have to round and stuff like that, you made a mistake. So, all right. But yeah, you can always try it. And honestly, that step right there doesn't take that long to do. and it could save you having to do another 2 of these problems. So that little extra time can save you a lot of time in the long run. So I would definitely think about checking them first. So, yeah, let's do another substitution one. They're not always going to be y. Just happens to be the first 2 problems came up to be y. If I make the problems up, they get to be crazy. So that's why I'm literally taking the ones they gave me. So same process. It doesn't matter which one's first, which one's second. So that doesn't make any difference. So this one, the first one was the y equals a problem. We're plugging it into the second one. I would have negative 4x plus 3. And then I put the 3x minus 11 there. Equals negative 13. So again, multiply negative 4x plus 9x minus 33 equals negative 13. Not because you made this mistake, but this is a very, very common mistake. Don't forget to multiply that times that. Most people will always remember to multiply by the first one. That second one is where people forget sometimes. And that's where you'll catch a lot of your errors in that respect. So don't forget that one. So we got 5x minus 33 equals negative 13. Add the 33. If these topics don't show up for you, my guess is that you did not finish all the solving of equation topics from chapter 2 or chapter 3. Wait, solving equations was chapter 2 because chapter 3 was the graphing. So yeah, I don't think you finished all the ones from chapter 2. So odds are you have to go back and finish some of those because you have to solve equations to do this. So that will most definitely lock these topics. So we've got x equals 4 for this one. So now I'm going to plug back that into my y equals. So y equals 3 times 4 minus 11. 12 minus 11 equals 1. So y is 1. So now I'll do my quick check. So negative 4 times 4 plus 3 times 1 equals negative 13. Negative 16 plus 4. Oh, wait, negative 16 plus 3. Yep. Tony's tired. Equals negative 13. Don't screw up your check, otherwise you're going to think you got it wrong, even though you had it right. So this one works out. So it's 4 and 1. Okay. That's really it with substitution. Everything else, when I'm showing them to you, is actually going to be easier doing an elimination method than the substitution method. So I'm actually going to make one up real quick because I want to show you one specific thing and I can't find a problem with it. Let's do All right. So in this problem, we can still do substitution the way that it's written, because I have this x basically by itself here. So what I would want to do first is change this problem by moving the 3x or the 3y over. So I'd have x equals 14 minus 3y. Okay. So sometimes if they put them all on one side, elimination might be easier to do in the long run, but these can be done by substitution just by moving one of them over. You basically only want to do substitution when you have one letter with no number in front of it. You don't want to have to do multiple steps to try to get your substitution in there. So we're going to take that problem and plug it back into my other problem. So I have -3. Now this time I have the x, so it's 14 minus 3y plus 5y equals 14. So we're going to multiply. So I have -42 plus 9y plus 5y equals 14. So -42 plus 14y equals 14. Add the 42 to both sides. 14y equals 56. Divided by 14. So y equals 4. And then we just plug that back into this problem. So x equals 14 minus 3 times 4 minus 12. So x equals 2. So we can do that for both of them. Okay. That's really substitution. That's what's known as the substitution method. The elimination method's a little more complicated. It's actually, once you see the process, it's actually pretty easy. It's just not something you normally would do. So. Yeah, I don't know why. It's okay. I'm not worried about it. 3x plus 5y. All right. So the elimination method of solving systems of equations can also be known as linear combinations. So what we're going to do with this one is we're actually going to add the two equations together. The goal of adding the two equations together is to get rid of one of the variables. Elimination or linear combination. So Oompa Loompa. So I like to call it the elimination method because you're eliminating one of the variables. Alex does also call it the elimination method. Most textbooks will call it the linear combination method because we're basically taking two linear equations and we're combining them. So when you're combining them, we're actually literally always combining them by addition. So we're going to add these two equations together. Yes. Yep, we're literally going to add them straight down. So when you do this, you want to make sure your letters line up. Most of the times when you're working on this, you want all the letters on one side of the equations, the number on the other side. So notice the x is lined up, the y is lined up, the number's lined up.
Sometimes you have to solve like you just did.
We're going to have to do some little things, some little modifications to it. The one that we're doing first, you don't have to do anything to on purpose. But I'll show you the other steps in a few minutes. So this case, if we add these straight down, what's 3x plus negative 3x? That's gone. That's literally why it's called elimination. We've now eliminated that variable. 5y plus 2i, 7y. Negative 3 plus 24 is 21. And now divide by 7. Y equals 3. Linear combinations typically are easy at the beginning, but now I don't have an equation that's solved for a letter just to plug my number back in to get. So we have to do a little more calculations in this step to find my second one. It doesn't matter which one you pick. We can choose either one of them we want. So let's take the first one because there's really no negative signs in it. So I have 3x. Stop making my 3 zeros. Plus 5 times 3 equals negative 3. So I have 3x plus 15 equals negative 3 minus the 15. So 3x equals negative 18 divided by 3. So x is negative 6. The same rule is true about this one. You can always use the other equation that you didn't use to check it and see if it works. So we can plug the 3 and the negative 6 into the other equation to see if it works. That's the linear, that's elimination. Now, the key with this one is, as you were saying, we have to get the equations to work so that one of them will cancel out, because they're not always going to be set up that one's going to cancel out. So the other steps that we're going to look at is how to change it so that that does happen. Okay. Let's see. That's fractions. Okay. So I'm going to make one up first. All right, let's do. Wait. Not 10. Oh, it's a 3 and 1. That's why. Okay, that's this one I gotta change. There we go. Just trying to make it actually come out to be a nice number. All right, so in this one, if I was to add these two equations together, I'd get 7x, 8y equals 29. I didn't eliminate anything. Okay, that's a problem. My goal with linear combinations or elimination is to eliminate something. So if I added these two equations together, I'm not eliminating anything. So we need to change the problem to eliminate something. So if you're looking at these letters, which one would be the easiest one to eliminate? The two y's both have 4's in them, right? So really the only thing I have to do is make one of them negative. Correct? And then they will cancel each other out. So what I'm going to do is I'm going to take one of my equations and change every one of its signs. So I'm going to make that one negative, and that one negative. Okay? You have to change. Yes. If you're going to make the change, you have to make all the change. And if it was a negative, you'd make it a positive. So you switch every sign. This one, they just all happen to be positives. What's up? Or that was you were going to say? Oh, okay. Not there yet. All right. So yeah, we just go through and change all the signs. And I personally always just change the second equation. All right, I just changed the bottom one. Doesn't make a difference. You could have changed the top one. Wouldn't have mattered. I just always change the bottom one. So now 2x minus 5x. Negative 3x. 4y minus 4y. Hey, it's gone now. 10 minus 19 is negative 9. Divided by the negative 3. So x equals 3. And now I take that and plug it back into one of the problems. So we'll do the first one at smaller numbers. It doesn't matter. They'll both come out to be the same. So y equals 1 in this case. And that's my answer. Okay, I'm going to do one more of these before I go on to adding the next step. Let's do. Let's make that. Yeah, that works. Yes. I don't want the answer. That's not helpful. All right. Good. You're going to be quiet because I'm going to tell this step by step. All right. So in this problem, do I have a letter with the same number? Yes. So I'm just going to change my signs. So I'm going to get rid of the y in this case. So I'm going to change my sign. So that now becomes a positive, that becomes a negative, and that becomes a negative. Okay, so I want to get rid of my y's. They both have 3. I just need to change my signs. So the negative is going to become a positive, and then my 2 positives become negatives. I wanted to do one where you actually had to change a negative sign to a positive. So you can see an example of that, because sometimes people just automatically make everything negative and forget the negative sign becomes a positive. So in this case, I got 5x plus 3x, which is 8x. The 3 y's cancel out. 25 minus 9 is 16. 8. So x equals 2. Now plug into the other one. So 5 times 2. Y equals 25. Subtract the 10 from both sides. And divide by 3. So y equals 5. And that would be the answer. So the first thing we need is we need a letter with the same number. As long as I have that, I'm good. The second thing we need is they have to have different signs. Okay, so those are the 2 things I'm looking for. As long as those 2 things happen, I can do my problem. If I don't have those 2 things, I need to make those 2 things happen. And that we've done the sign. Now we're going to look at how do we get the numbers to be the same. Good? All right. got negative 5x minus 3y is 24. And negative 4x minus 5y equals 1. All right, so in this problem, do I have a letter with the same number? No. So at this point, you can technically choose your number. If you have a number that's easy to work with, use that one. In this problem, I really don't have one number that's easier than the other number, so it doesn't actually matter. So which letter do you want to get rid of, the x or the y? All right, so all we're going to do is we're going to take the first equation, and I'm going to multiply by 4. And my second equation, I'm going to multiply by 5. Why? Think about where that 4 and 5 came from. They're the opposite x. So I'm going to take the bottom and multiply by the top, top multiply by the bottom. So the bottom x was 4, so I multiply the top equation by 4. And the same thing with the 5. Okay? Because the goal is to get them to be the same number. So if I multiply that whole first equation by 4, I get negative 20x minus 12y equals 120. If I multiply this one by 5, I get negative 20x minus 25y equals 5. I now have a letter with the same number. And it'll work every single time. The signs are the same. So now we just change the signs. So now I'm going to go positive, positive, negative.
Another way to do this?
What do you mean?
Are you just doing the same thing a different way?
This problem and this problem that we just did, same exact steps. The only thing that this problem didn't have, that the one before it did, is it didn't have a number that was the same. So I needed to make it the same before I did my signs. So that's why we had to do the multiplication step first. If you look in the books, if you look in Alex, it'll tell you to multiply by a negative 5 instead of a positive 5 in this problem. Okay? It wants you to do these two steps that I just did at the same time. All right? I will tell you, easy way to make mistakes. Okay? When you're doing your multiplication, always make them positive, just switch the two numbers. Okay? Just ignore the signs and switch the two numbers. If you need to fix the signs in the second step, because it's really quick and easy to do. It's really easy to make mistakes when you're trying to multiply things by negative numbers. Or you'll end up multiplying them both because you'll take the negative 4 and the negative 5, and then you'll still end up having to change signs. So there's lots of little places that you can make mistakes in that. So it's easier just to do it as two steps. Okay. All right. Now that we got one with the same number and a different sign, we add. So the x's are gone. I have 13y equals 115. I divide by 13. So y equals what's 115 divided by 13? Calculator. Not an even number. Where did I screw? Hold on a second. Let me make sure I wrote the problem right first. We'll start with that. Okay. So remember, I said if things come out to be decimals and stuff like that, you want to look and make sure we didn't make a mistake. So step one, I want to make sure I wrote the problem correctly because I copied it over and that could be easily a mistake. All right, so I copied the problem correctly, so that's step one. Then we just make sure I didn't make any mistakes in my calculations, which We've known I have. And I did, actually. I did. 4 times 24 is not 120. That's the mistake. 4 times 24 is 96. I did 5 times 24 is what I did in my head. Okay, so I would have gotten 91 divided by 13, which is 7. See, those are the things, but it's like, as much as, yes, I don't like to make mistakes, it's always little mistakes that you make, and it's understanding how to catch the mistakes and fix the mistakes is actually a more important skill than being perfect every single time. So, all right, so we got y is 7. Now, pick one of the problems and plug it back in. Don't pick what you did. Go back to the original problems. Yes. Yeah, go back to the original problems. So negative 5x minus 3 times 7 equals 24. Negative 5x minus 21. Add 21. So negative 5x equals 45. So x equals negative 9. Let me make one up, actually. Let's do. All right. So this problem. Which letter do we want to get rid of? And why? Why? Okay, so we're going to get rid of the x, but not the way that you just said it. Yes, that's the way I just did it, and that way would work. Okay, there's a reason, though, the way I wrote this problem was very specific. So we could do it, just switch the 3 and the 6 if you wanted to. And actually, if you were going to do that, I probably would switch the 4 and the 3, just because the y's are already different signs, and I don't have to worry about changing the signs. Okay? So this is one of those problems when you look at it, figure out what's easiest for you. Okay? So the 4, I have a negative 4y and a positive 3y. So if I was going to multiply, get rid of the y's, I can multiply the first problem by 3, the second problem by 4. I already have different signs. I don't have to worry about changing my signs, which is nice. However, if we look at the x's, I have 3 and 6. What do we know about 3 and 6? They're related to each other, right? 6 is just 3 times 2, correct? So I don't always have to swap the numbers. Okay, think about it like common denominators. You don't always have to multiply the two numbers to get the common denominator. Sometimes we can multiply one of them to get a number that works out to be the same. That's what I can do here. So instead of multiplying all the problem, I'm just going to multiply the first problem by 2. Because what that gives me is 6x minus 8y equals negative 30. And this one stays the same. Okay? If you can figure that out, it's great. And it'll make your life easier. It'll make the number smaller, make it easier for you to do your calculations. If you can't, the other method I showed you, just switching the numbers, that'll always work. Okay? This way just is a little bit easier to figure out. Now, same thing in this one, though. I do have to change my signs. So I'm going to change all my signs in my second one. And now we combine the numbers. So the x's are gone. Negative 11y equals negative 66. So y equals 6. Now plug back into my original problem. 6x plus 18. So x equals 3. And those are my two answers. So it's just like common denominators in that respect. It's find something that works with the two of them, you're good. Okay. But I could have easily done this one by multiplying the first equation by 3 and the second equation by 4. The numbers would have just gotten a little bigger. So, okay.
You can only do that if, like, the 3 and the 6, and the 6 is the
Yeah. Yeah, if it was 3 and 5, it wouldn't have worked. I would have had to switch the numbers. Because the goal is to get the numbers to be the same, just like we're trying to do common denominators and get the denominators to be the same in fractions. So that's what we want. So you can do it any way you want to get those same denominators. And in common denominators, I said the quick way to do it was just to multiply the two denominators. That's in essence the quick way to do this as well. If you can figure out an easier way to do it the easier way. But if you spend too much time trying to figure that out, just switch them and multiply. Okay? All right, now the hard problem. Hello, fractions. What? What's the answer?
Okay, the answer to this one, so basically, it would be you're taking the negative 2, putting it over 5, so.
No, I want the answer. I don't want the steps. What's the answer? I'm like, if you can figure out the answer that fast, have a nice night, go home. I couldn't figure out the answer that fast. All right. The thing that sucks in this problem is the fractions, right? Let's get rid of them. Okay? Seriously, let's get rid of them. The easiest way to get rid of fractions, we've already done this actually when we're solving the equations. Multiply by the denominator, fractions go bye-bye. So before I even start this problem, I'm going to multiply this whole first problem by 5. And this whole second fraction problem by 6. Okay? The 5 is easy. They were all the denominators are 5. The bottom one I did 6 because I just multiplied 3 times 2. Remember, you're basically looking for a common denominator. So my first problem comes out to be 1x minus 10y equals negative 2. My second one comes out to be 2x plus 3y equals 42. Hey, look, no more fractions.
Basically the same as the other.
So many
Yes,
speak forever.
yes,
Yeah,
yes,
we're
it does.
about the first step.
And so all three methods, the graphing method, the substitution method, the elimination method, will give you the same answer. Okay? When we do the test on this, if I'm asking for substitution, I want to see substitution. If we're asking for elimination, I want to see elimination. Okay? However, when we're doing the word problems next week, we're going to go back to graphing. Because we have Desmos that can do the graph for us really quickly and easily. So we're going to use that, we're going to harness that power to be able to graph them and get the answer. All right? Because at that point, I'm more concerned with you coming up with the equations for the problem and then understanding that the solution is where they cross than going through and doing this whole process out of elimination or something like that. Because I'm testing that here when I'm giving you the problem that says do elimination method with that one. So when we move to the word problems, we're going to be doing graphing and using Desmos for it. So, okay. You also, when you're doing these problems, if you want to use Desmos to check your work, you can. It'll give you the same answer. Okay. But do practice this a little bit so you understand how to do this process, because you will have to do at least a couple of these on the test. So.
This next test.
Yeah. So it'll probably be one substitution, two elimination, and then like a few word problems and stuff like that that I'm going to expect you to do the graphing on. So, all right. So now this one, we've gotten rid of our fractions. So we've got to get rid of one of the letters now, right? So let's get rid of the x because I've got 1x and 2x. That kind of makes my life a little easier. So I'm just going to multiply this whole first problem by 2. So I've got 2x minus 20y equals -4, and 2x plus 3y equals 42. Flip all my negative signs. So -23y equals -46. See? Be careful with your wording. So y equals 2. Sometimes I have noticed these come up with fractions. Okay? So I'm going to actually show you another way to do this one in case you get a fraction. Because if you get a fraction, you're probably not going to want to plug a fraction back into the problem to get the other one. All right? So I'm going to show you another way to do this. Really? Didn't check that too. All right. We're going to do the exact same thing. Except this time, I'm going to get rid of the y. So I'm going to multiply the first problem by 3. Yes. What's up? Okay. I'm like, it's possible I did too. So that's why I figured I'd ask. All right. So we're going to multiply the first problem by 3 and the second problem by 10 because I'm going to get rid of the y now. Okay. So if it's a whole number, I wouldn't go through and do this work. It's easier just to plug the other number in and find it. But if you do get one that comes out to be a fraction and you checked your work and you know it's right, this method actually will be easier to do. So we're going to multiply the first problem by 3. So I got 3x minus 30y equals -6. And the second equation by 10. So 20x plus 30y equals 420. Notice my y's are now the same number and different signs. So I can just add. So 23x equals 414 divided by 23. And I don't know that off the top of my head. I know what's wrong with me. So x equals 18, and that's my answer. So you could just do the elimination twice. That'll work. So if you get something crazy with that first one, or if it's a fraction, you can't plug it back in or whatever else, which sometimes in the fraction ones it can happen, just do elimination again. Okay. All right. That's probably the hardest problems you're going to see is the ones with the fractions, besides the actual annoying word problems that we're going to do. There's one more topic I want to cover, and then we're done for tonight. And I'm back. All right. So in this one, when you do your elimination or your substitution, whatever it happens to do, crazy things could happen. Okay? If crazy things happen, I need you to see what those crazy things are. So let's look at the first one here. So I got negative 5x plus y equals 5, and 5x minus y equals 5. Okay? Do I have a letter with the same number? Does it have different signs? Good. So I don't have to actually do anything. All right. So this is going to be gone, and that's going to be gone. So I have 0 equals 10. Right? Because everything on this side cancels out. Does that make sense? Does 0 equal 10 make sense? No. So this has no solution. Okay? If this answer right here makes no sense, it has no solution. Okay? Yeah, actually, which is why I did this one. Otherwise, I'd have looked for another one. All right. Same thing with this one. I have a letter with the same number, a different sign, so I don't have to change anything. What's 4x minus 4x? Gone, right? Negative y plus y. Gone. So that's 0. What's 8 minus 8? Hey, that does make sense. 0 does equal 0. Okay? If you get something that works, well, not that works, but that looks crazy but actually is true, it is infinitely many solutions. Okay? Because this works. 0 does equal 0. So that is infinitely many solutions. When you do that option, though, you have to tell them what the line was. So you have to take one of these equations and solve for y. I would choose the y that has the positive sign. So we have negative 4x plus y equals negative 8. I'm just going to add 4x to both sides. So y equals 4x minus 8. So this right here is 4x minus 8. And that's how you put that answer. So those are the two crazy things you can see. If it comes out to be normal like all the other problems, it's the one unique solution. You just put your x and y in there. Okay? But those are the two crazy things. You can have it so that it doesn't work and it's no solution, or that it does work, does make sense, but it looks crazy and it's the infinitely many solutions and you have to solve one of the equations for y. And it doesn't matter which equation you solve for y, they're both going to come out to be the same answer. Because that's the point of it. It's the same line. They just wrote them differently. Okay? That's it.
So.
This would have taken your high school teacher at least a week, if not 2.
What?
I said this would have taken your high school teacher at least a week, if not 2, to actually teach you.
Well, when you have large classes.